Assalamualaikum warahmatullahi wabarakatuh. We are Group 43 from Engineering and Society. We'll be presenting our analysis on Chevron Richmond refinery fire which occurred in California, USA in 2012.
These are the table of content that will be discussed in this project, starting with the introduction, discussion, technical and engineering issues, ethical reason for failures, recommendation, and lastly, the conclusion. On August 6, 2012, a major fire occurred at the Chevron Richmond refinery located in a densely populated area of Richmond, California. The root cause of the accident was the failure of a carbon steel pipe that has severely corroded over time. Although previous inspection had flagged the pipe as vulnerable, it was never replaced. This oversight, along with poor maintenance practice and weak decision-making, led to a critical system failure. Let's take a brief look at the timeline of key event. As early as 2002, internal inspection report flagged a specific carbon steel pipe as vulnerable to corrosion. Multiple recommendations were made to replace the pipe, but they were not followed. Then refinery workers detected a leak but decided to keep the unit running while investigating the issues. In the evening, the accumulated vapor ignited, resulting in a massive fire. Post-incident investigation led by the US Chemical Safety Board confirmed that this event was entirely preventable from long-standing technical and organization failure. This shows not just a technical failure but also a breakdown in safety culture and decision-making. The company continued operation even after detecting the leak, putting production above safety. The impact was serious where over 15,000 people needed medical care and toxic smoke affected nearby communities. This case is very similar to the BP Texas City explosion in 2005 where known risks were also ignored. Both incidents highlight the need for strong engineering ethics, better communication, and a proactive approach to safety.
Hello, I'm Iman and I will be presenting the technical issues. Leak and the rupture was caused by sulfidation. Sulfidation is like corrosion that is specifically caused by sulfur under high temperature. Since the refinery unit handles crude oil, which commonly contains hydrogen sulfide, then it should be expected that the material can handle it. In the 1980s, studies discovered that carbon steel pipes with higher silicon content can slow down sulfidation significantly. Hence, in 1985, ASTM and API dictated that carbon steel pipes should have minimum 0.1 weight% silicon. However, the refinery unit was built long before 1985, leading investigators to believe the possibility of old pipes still being used. Investigation analysis shows multiple pipe sections measured under 0.1 weight% silicon. So, was the entire unit remain unchanged for more than 3 decades? Investigators also analyzed the elbow section, which seemingly in good condition despite being directly upstream to the rupture section, and they found that it was up to standard. That means modernization was done selectively on sections deemed critical or high load, while neglecting other sections.
Ethical reason is one of the main causes of the Chevron Richmond refinery fire, especially about negligence in equipment maintenance and risk awareness. The fire was caused by the rupture of severely corroded pipe that carry hydrocarbon fluid. And upon investigation, Chevron management is fully aware of this situation but chose to continue with the operation instead of stopping to replace the corroded equipment. This decision clearly shows that Chevron put operational continuity on top, neglecting the safety of their workers and surrounding communities. From an ethical aspect, this is a disregard for professional responsibilities and the failure to uphold the core principles of engineering, which is to protect the health, safety, and welfare of the public. Next, Chevron also have weak safety culture, where they put economic consideration above human life and environmental responsibility. When the incident happened, thousands of residents is exposed to the toxic smoke, but many reported that they received little to no warning from the authorities. This shows that Chevron lacked in emergency response and public communications. On top of that, the company also lacked transparency and accountability when operating high-risk industries, which put the safety of their workers and surrounding community at risk. Lastly, even though Chevron complied to the legal requirements for plant operations, they failed to meet with the broader ethical responsibilities as an organization that handles dangerous materials. In ethical aspects, companies are expected to go beyond the basic compliance with regulations, especially when the human life is at stake. However, by continuing operations with ancient equipment, ignoring the internal safety issues and lack of transparency in operations, Chevron breached its duty of care. This incident is a clear example of what can happen when ethical responsibilities is ignored. Hence, this incident also highlights the importance of ethical leadership and the importance of health and safety, and most importantly, the prioritization of human and environmental well-being over economic gain.
Hi, my name is Bevin, and today I'll be talking about my recommendations to prevent future problems, such as the Chevron refinery fire incident and other oil and gas related incidents. These recommendations are based on the root causes that led to the Chevron incident. Firstly, would be for material section and upgrades, which is to replace the carbon steel in corrosive environments and specify minimum silicon content. Secondly is to enhance inspection and monitoring systems, which is by implementing a positive material identification system, PMI, and use advanced non-destructive testing techniques. Thirdly is to apply risk-based inspection and maintenance planning, which is to adopt a risk-based inspection approach and update asset integrity programs. Thank you.
In conclusion, the Chevron Richmond refinery fire could have been prevented if the known corrosion risk had been addressed earlier. The pipe that failed had been flagged in previous inspections, but no replacement was done. This reflects a gap in both material standards and inspection strategy. Our recommendations target consists of 3 main areas. Firstly, by replacing vulnerable carbon steel with corrosion-resistant materials. Secondly, by improving inspection methods using PMI and non-destructive testing. And lastly, by adopting risk-based inspection and updated maintenance planning. These steps are essential to uphold safety, prevent future failures, and maintain compliance with engineering standards.